Hello and welcome to another math video. Today we're continuing our work on our FST final exam study guide, starting with problem number 28, and we'll be going to problem number 34. So this first question here, determining whether the relation is a function. So this relation is defined by a set of ordered pairs. The key here being that all of our inputs are different. We've got a -1, a 2, a 6, an 8, and a 12. So again, in order for a relation to be a function, each input has to have exactly one output. So each of these only has one output, none of them have two or more. So yes, this is a function. However you want to write that, yes, it's function, whatever. But yes, that relation certainly is a function. Moving on to 29, however, we don't have to go too far to find that we have -8 goes to 2 and -8 goes to 8. So this is an issue for this relation being considered a function because, again, that one input of -8, it's either 2 or it's 8. So that does not work very well when you need to figure something out. It creates problems. So it doesn't function well when your relation has more than one output for any given input. So this is not a function, again, because we have that input of -8 has more than one output. It doesn't matter that the 1, 6, and 10 work just fine. All that matters is that the -8 does not. Then we switch gears a little bit, determining whether the relation defines y as a function of x and also give the domain for that relation or function, whatever that might be. And again, it's really getting down to the same question. For every input that's possible for x, is there only one possible output for y? And mathematically what happens here is if we plug a number in here for x, we multiply that by 3. There's, any value of x you plug in there, you multiply by 3, there's only one result you can get. Whatever that number is, you take 6 away. Well, there's only one number you can get for that. You square it, whatever that number is, there's only one number for that as well. So no matter what you plug in for x, there's at most one real number answer for y. Now, we do run into the issue, so I guess that means that yes, it is a function, and I can talk a little bit about what would make something not a function as well, just to go over that also. But that is a function. Fix that up a little bit. But we do run into a restricted domain here. Again, the domain is all the values from the set of real numbers that you can plug in for x, for which you get a real number output for y. The issue there is when we square root something, if we square root a negative, we get a non-real answer. And so we can only square root non-negative answers. So really that 3x minus 6, the part that's getting square rooted, has to be greater than or equal to 0 in order to give us a real number output. Well, so we just solve that inequality. In this case, it works out pretty well. We just divide by the 3 here. We get x is greater than or equal to 2. And we see, oh, as long as x is greater than or equal to 2, we plug any of those values in here, and we're square rooting some kind of non-negative answer. Of course, if x is exactly 2, we get 6 minus 6, which is 0, and we can square root 0. The result is just 0. So, but that is the smallest value. 2 is the smallest value we can plug in for x, where we're still square rooting a non-negative answer. So that describes our domain. Now, again, we're a little bit more complicated. We write our intervals in interval notation. So in interval notation, that would say from 2 to infinity. So that's how we would write that. That's what you'd expect to see in a multiple choice option. So yes, it's a function. The domain is limited. The domain goes from 2 to infinity. Again, just to go over real quickly what would happen for something that's not a function. If you had y squared equals 3x minus 6, so practically the same thing. One of the first things you would need to do to determine whether the relation defines y as a function of x is you have to solve the equation for y in the first place. This one's very close to being solved, but we'd have to square root both sides of the equation. Now, the thing that we have to remember when we square root both sides like that, we have to include the plus minus. So now when we start at a slightly different spot, we get y equals plus or minus the square root of 3x minus 6. Well, now, because of that plus minus, now I plug in that one value for x, I can get more than one value for y. So that y squared equals 3x minus 6, even though it looks very much like what we started with here, this is something that is not a function. So that's how you get something that's not a function versus what we had, which is a function. So continuing on with 31, same idea. Does the relation define y as a function of x? And what would the domain of that function be? And again, with this one, whether the relation defines y as a function of x or not, you pick any x value from the set of real numbers. You plug it in, you add 10 to it, you're going to get some real number answer, but there's only going to be one value. You divide -4 by whatever that is, and there's only one answer. So yes, y does, or the relation does define y as a function of x. However, the one thing we can't divide -4 or any other number by, really, is 0. And x plus 10 can equal 0. So if x is -10, then the denominator is 0. So that value is not included in the domain. So we might just say x can't be -10. Of course, again, we're a little bit more complicated than that. So we would write this in interval notation. We'd say, well, from -infinity to -10, all that stuff is okay. Again, notice the parentheses, so we're not including the -10. But then also, everything from -10 to positive infinity would be okay. So this would actually describe the domain for that function. Again, what that really does on a number line is it covers everything except for -10. There's just a little hole there. Anything else works, it's just that one particular value that does not. Moving on to number 32, little function notation stuff here. We're going to find g of a plus 1 for this function, g of x equals 3x minus 5. So really all we're doing there is switching our input from x to a plus 1. So g of a plus 1, so the 3, and then instead of the x we have our new input, a plus 1, and then we have the minus 5. So it's still really 3 times the input minus 5. Just now the input, instead of being x, is a plus 1. So we simplify that. We would start by distributing that 3, and then we would combine the 3 and the 5, so we get 3a minus 2. So that's what g of a plus 1 equals. It equals 3a minus 2. All right, then we'll get to our last two questions, solving systems of equations. So this first one, they do mention they want us to solve using substitution. So I'll show you that method. And it's set up to be used with substitution, and so we'll talk about that a bit as well. Again, they do mention inconsistent or dependent equations say so. Inconsistent would mean there's no solution. Dependent would mean there's many solutions, and we can talk about that a little bit as well. In this case, again, x is -10 plus 4y, so we go into this equation and replace x with -10 plus 4y. If you didn't begin with an equation like that was already solved for x or y, that would be the first thing that you would try to do if you're planning on using substitution. So notice this second equation now, all we've done is replace the x with -10 plus 4y. That gives us an equation where the only variables are y's, and so I can go through solving this one. We get -70 plus 28y minus the 5y, that's a 5. Maybe redo that, that's 5, equals 22, and that's an equal sign. I do have some like terms on the left side there with the 28y and the minus 5y, so -70 plus 23y equals 22. Add the 70 to both sides, so plus 70, we're going to get 92 on the right side, so 23y equals 92. And it might seem like this is going to turn out poorly, but it actually turns out where y is 4. Now, one of the nice things about a multiple choice test is 4 is not going to be one of the choices, which for free response tests, I had a number of people that stopped at this point. Again, that's really only half of the answer. Yeah, we know y is 4, but we also then need to use that value in order to find out what x is. You could really use either of those two equations, but that first one is already solved for x, so may as well use that one. We get x equals negative 10 plus 4y, so negative 10 plus 4 times 4, so negative 10 plus 16, so we're looking at x equaling 6. Again, it is a system of equations, so once I get the answers, I should be able to plug those back in here and make sure that they do actually work. Now, of course, it should work on this one because that's where I just got that from. So it might make more sense to check it here. So I get 7 times 6, which is 42, minus 5 times 4, which is 20. 42 minus 20 is 22. So yeah, it certainly appears that 6 and 4 is the answer. Now, it might also be written as an ordered pair, as a multiple choice option. Hard to know exactly how they'll do that, but certainly you just need to be able to recognize that. And if this had no solution, what we'd end up getting is a situation where when we're going through our solving process, all the variables go away and it's a false statement like 0 equals 10 or something like that. And if it ends up being a dependent equation where there's many solutions, it'd be similar, all the variables would go away, but we'd get a true statement like 23 equals 23 or 92 equals 92, something like that. Moving on to 34, they want us to use elimination here. Again, it's just a little bit different method. And this one's really set up for elimination. Notice how the x's, the y's, the equals, and then the other number are all lined up. So it's really ready for elimination. Now, in this case, if I were to just add these equations together, it wouldn't do us much good because it wouldn't cancel out any of the variables. If I look at the x's, I'd probably go for like a 10x and a negative 10x. That would require me to multiply both equations. If I look at the y's, I could probably keep the top one the same and then just make this a minus 8y by multiplying by negative 2. So for me, I would probably lean towards multiplying that second equation by a negative 2 because then I only have to do the one thing. So I'm just going to rewrite the top equation, 5x plus 8y equals negative 25. And if I multiply the bottom one by the negative 2, I get 4x minus 8y equals negative 20. And be careful with your adding here. Make sure you pay attention to the signs. We get 9x plus 8y minus 8y, and then we get negative 45. Dividing by the 9, we get x equals negative 5. Again, that is not the final answer. That's part of it. We need to use that answer to, or that part of the answer to find the rest of the answer. So I'm going to come back up here. It doesn't make much difference in this case which equation I plug it into. I think I'm just going to use the top one. So we have 5 times negative 5, because that's what x is, plus 8 times y equals negative 25. So we get negative 25 plus 8y equals negative 25. Well, that's kind of interesting. So we add the 25, and we get 8y equals 0. Now, sometimes this messes people up, but really we just divide by 8, and we find out, oh, hey, look, y is 0. Again, this may be written as an ordered pair for a multiple choice option, negative 5, 0, and pretty simple to double check and make sure that works out, especially with the 0 in there. So certainly worth your time to do that. And that is actually where we're going to stop. I know I did 35 is where I began another video. So as always, thank you for watching, and hopefully you found this helpful.